All right. If we have no other questions, then what I want you to do is I want you to get out your calculator. I'm gonna mask it up as well. So I'm gonna ask you to do the same thing, because this I want you to be comparing with each other what you're getting on your calculator, okay? So compare with each other. Let me turn the Zoomers around so you can feel like you're part of the class. Hopefully, have you guys all figured out how to see not only my screen, but how to see the classroom as well? Brianna, did you figure that out?
Yes, ma'am. It was the browser.
Oh, who knew? Yeah, okay, good to know. Justin, November, and Blake, did you guys figure out how to see the class as well as see the screen?
Yes.
Yeah, I can.
Perfect. All right, so what I'm gonna do then is, the very first thing that it says here is let's graph on the calculator. So you've got 4 graphs. One of them, the first one is the parent. Now remember, you had to memorize the shape of the parent. So you should already know what the first one looks like because you've already memorized that. And so what you're gonna do is you're gonna graph the parent in Y1 and then graph the other 3 as well, all on the same screen. I want you working together with this. Again, you have to socially distance, but you also I want you working together, okay? So pull out your calculators. Let's go ahead. By the way, if you don't know where to go on your calculator, well, first I'll just stay on your case because you didn't watch my video. But second, ask the person around you, how do you do this? Okay, so let's go ahead. Go. If you didn't bring a calculator today, you can use Desmos on your phone. You can use Desmos on your computer. You can do that during class, but you may not do that on a test. Okay, but I don't mind if you do that during class until you get your calculator. But let me tell you, you may not use your phone on a test. So. No. All of them.
Are these
Now, if
notes
you
that we
want to one at a time, that's fine. To see how they differ, that's fine. Right. But what I really want you to do is to start comparing screens. Okay, so you'll need to put your mask on, start comparing screens with each other. See if you guys are getting the same as what other people around you are getting. I have not used it. So. But you can ask somebody around you, Jacob, which is what you were supposed to be doing. Exactly, you can find that phone with them. Okay, you guys are. They're not gonna bite, and they probably don't have COVID. Okay, and as long as you don't breathe on each other, it'll be okay. All right, so. So just compare. I don't care if you're using the graphic calculator or the Desmos, either one. You should still have the same screen. I don't know how to put you guys in your own rooms so that you can. Oh, nice. Well, that works. Thanks, Justin. Cool. What's that? It's not set right now for me for permission to do that. Because that's not an automatic permission, it's one that I have to change every single time I get into Zoom. And yeah, and I have to do it from there, which means I gotta get out of my sharing screen and go to the That's too much work. Okay, so the whole goal here is that we're supposed to graph. Now, we already knew what the parent looked like, okay? Because we've already learned that. That was in section 2.1 in my library of functions. All right, so yeah, so what is it that Y2 does to the parents? Okay, well, but no, that's because Y2 and Y1 are both parabolas. Okay, so what is it that graph Y2, how did it mess with the parent? Yeah, it shifted it up. How far up did it shift? 3 units. Okay, so then go to Y3. What did Y3 do to mess with the original parent? Yeah, it shifted down to, and then Y4, what did it do to mess with the parent? It shifted up 5 units. Very good. All right, so then go to the next little set of directions here. Not directions, but rules. So f of x is just simply my parent. Okay, that's what we're gonna call f of x. That's who your daddy. Okay, and c for right now we're just gonna let c be a positive number. Okay, it doesn't have to be, but for right now, for our sake, that's what we're gonna let it be. And so how did these guys move? Describe to me what kind of direction did these guys move? Up or down, okay? So they moved up and down. And my parent's equation is, here it is, or not my parent, but the kids that are messing with the parent. Here's my parents, and I'm adding or subtracting a number, okay? Notice that kid is not inside the parents, okay? That kid is parent plus something or parent minus something, all right? Now, so if the equation then says parent plus a number, what can we assume our graph is doing? Up how far? C, it's gonna go up C units. And then if my equation says parent minus a number or parent minus C, what can I assume that my graph's gonna do? It's gonna go down C units. All right, next. So here's another set. I want you to do the same thing. Now, well, hang on, before you start graphing, take a look. Who's your daddy on this one? Who's the parent on this one? Yeah, it's my square root function, right? The square root of x. Do you notice that I'm still adding and subtracting? Okay, which is what I was using before. But now, where is my adding and subtracting? It's inside the parent. Before it was outside the parent, made it move up and down. Let's go find out what's happening here. Okay, so graph your parent, and then graph a couple of the others. I don't care if you graph all 4 of them or not, but graph a couple of those, and then check it with somebody around you. By the way, you should already know what this guy looks like without even graphing the parent, right? He's the swoop. Remember that? So get the parent and at least one other in there. Yeah.
So I was looking for it, but I guess I'll just this one finding it on where like I went to where it says video and printable notes.
Course notes for printing?
Yeah, that one.
Yeah.
But I couldn't find it. So.
Oh, Jacob. Okay, so when you go into course, now you guys are gonna have to help me out. Make sure I'm telling them the truth, okay? When you go in the tab, course notes for printing, there's 2 more tabs under that. One of them says course notes for printing, and one of them says videos.
So that's my wrong.
You gotta
I just
read.
want the videos.
You gotta read.
The videos. And I was like,
Am I telling the truth? Is that how you get to them? I'm making sure. Because I do teach 3 different types of classes, 3 different MyLab setups, and I just want to make sure that I was telling you the truth. Okay, so did you guys check with somebody around you? You guys have the same thing? Okay. So we already know that the parent is the swoop, right? Because this is adding and subtracting, did this go up and down like the last set? No, it didn't, did it? It went which direction? Right and left. Interesting. Okay, so what did Y2 do? It shifted to the left 3? To the right 3? Hey, which one is it? Is it to the left 3 or is it to the right 3? It's to the right. To the right. Now here's what's weird. In the last set, when it said plus a number, it went up. Made perfect sense, right? And when it said minus a number, it went down, which made perfect sense. This is backwards. When it says minus 3, we expect it to go to the left, but oh, no. It's going the opposite direction from what we expect. It's going to the right, okay? So, again, set of notes. F of X is one of my parents. C is a positive number for now. Which direction are we moving here? Left or right? Okay. Now, will you notice here that my C is now on the inside of the parent? It's on the inside. Look, if you are like, what? Go back and look at the last set that we did like this. It was on the outside. Okay? This is the parent, but the plus and the minus is on the inside of that parent. So if the equation says f of x plus c, what is my graph doing? To the left, C units. To the left. And if it says f of x minus c, it's going to the right. And let's make a note here. Up by the direction moved, this is backwards from what you expect from the expected. It's backwards from what you expect it to be. Okay? Because when it says minus, we're going to the right. When it says plus, we're going to the left. Okay, let's write our own equation. So I just gave you a list of like 8 equations and made you graph them all. But let's take now a set of words and let's write the equation that goes along with that set of words. Okay, I'm going to take this off. It's loud under there. I don't know about for you, but it's loud for me. Okay, go to example 2 because that's the highlighted one. Example 2. All right, so we've got the absolute value function. Let's stop right there. Absolute value function. Do you remember how in section 2.1 on the library, I told you you had to memorize 3 things? Right? What were the 3 things you have to memorize about all of my library? And now I'm going to start calling them all of my parents because that's who they are. Okay, I had to know their names. So something like the absolute value function, that's its name. Or the squaring function, that's its name. Or the cube root function, that's its name. Okay, so I have to memorize the name. What else do I have to memorize? The equation. I gotta know what kind of equation does that parent have. The squaring equation, y equals x squared. Oh, I need to know what kind of an equation the absolute value parent has. What does the absolute value parent equation look like? Y equals the absolute. What does absolute value of x look like? The bars, right? Just the bars. Okay, so now I know the equation. Now, what's the third thing that you had to memorize? Yeah, the picture, the graph. Now, I don't need that for this, but I'll need it in a bit. Okay? All right, so number 2, we've got the absolute value function. It is shifted 3 units to the left. Now, question, if it's 3 to the left, if it's to the left, is my adding and subtracting going to be inside the parent or outside the parent? Inside the parent. All right, so this is going to be, you could say y equals, or you could say f of x equals. And you say, do I have to say that? It's an equation. Equation. What's the root word of equation? Equal. You have to have something equals. We call that y or f of x, either one, I don't care. Okay, so we've got y equals. Now you said absolute value of x had bars, and you also told me that my 3 to the left had to go inside the parent. Okay, how am I going to write that inside the parent? X plus 3. Why am I writing x plus 3 when it's going to the left? Yeah, whenever we're inside the parent, when I'm adding or subtracting, it's opposite from what we expect it to be. Backwards from what we expect it to be. Okay, look at number 3. Okay, squaring function. That means you need to know what the equation looks like. The squaring function is shifted 100 units right and 255 units up. What I want you to do, don't say a word. I want you to write an equation. Okay, write an equation. It's the squaring function, shifted 100 units right, 255 units up. Write an equation. All right. Now, when you write that equation, I want you to show it to somebody around you. So write down the equation, show it to somebody around you. See if they got the same thing. Guys, if you and a person close to you have something different, that's okay. That's okay. Remember, you're here because you don't know all of Math 110. Okay? So if you're wrong about something, that's all right. This is the place to correct it. There is no shame in that. All right? That's okay. Don't be scared. He doesn't bite. I've taught him before. He doesn't bite. Well, not horribly. The guy that was sitting next to him did drop the class, but you know. Okay, so squaring function shifted 100 units right, 255 units up. Okay, so I got 2 things going on. All right, let's just deal with them one at a time. So squaring function. Let's stop right there. What's the squaring function look like? Y equals x squared. Okay, so I need to have a y or an f of x equals. Tell you what I'm going to do. I'm going to do f of x equals simply because I did a y equals last time, and I don't want the f of x equals to feel left out. It's the best reason I got. Okay, but just to show you that I can use either one, it's not a big deal. And so that's the squaring function. So I've got my y equals. Okay, so something squared, x squared. 100 units right. Is that going to go on the inside of Downy, or is that going to go on the outside? Inside, okay? So, so tell me, somebody, let's see here. I'm just going to pick on, let's pick on some Zoom people because I don't ever get to hear you guys. Who am I going to pick on? Hey, Blake, how did you write the 100 units part?
I put in parentheses x squared minus 100.
X squared minus 100. Do you have any parentheses there, Blake?
Yes, ma'am.
Where are they?
Before the x squared and after the 100.
Okay, Blake, can you see my screen? Is this what you have so far?
Yes, ma'am.
Okay. All right, so I haven't dealt with the 255 yet. Okay, so, but wait, there's more. But let's talk about this. Okay, what are your thoughts on this?
If you say whatever it's.
Yeah.
So it's.
Okay, so, hey, Blake, somebody here is saying that it should say plus 100 instead of minus 100. Can you explain to us why you said minus 100?
In horizontal shifts, it's the opposite.
It's the opposite. So since it's 100 right. So it's okay, Blake. Dylan just can't read, so it's not a problem. It was actually Dylan's fault, not yours. Okay. What other thoughts do you have on what Blake has? By the way, how many of you also have the same thing that Blake has? Anybody? Okay, Zoomers, how many of you guys have the same thing as Blake? Okay. So if you don't have the same as Blake, what are your thoughts on this? What do you think, Mary Alice? Okay, so Zoomers, if you can't hear her, she said that the square goes outside of the parentheses. So here's my question. The way that it's written right this minute is minus 100 inside the parents. Now, I'm going to agree with you that it's inside of parentheses. Don't we all agree that the minus 100 is inside of parentheses, it's inside group? But is the minus 100 inside the parent? Now, who's your daddy here? Who's the parent? It's the squaring. So is the minus 100 inside the squaring? No, it's not. All right, so Blake, can you think of a way that we could fix that then?
Put the square on the side.
Yeah. So now my minus 100 is inside the squaring. It's not just inside a group, it's inside the parents. Does that make sense? Okay, all right, so let's talk about the last part. 255 units up. Ups and downs, where does that go compared to the parent? It goes outside the parent. So what should I do with that to get that in there? Plus 255. Okay. So that is a really, really common mistake, and probably a third to a half of you made the same mistake. So, folks, mistakes are where you're learning. I don't feel like I have a whole class full of people who make mistakes. I'm like, woo! I got people who make mistakes. They're gonna learn this semester, okay? So don't feel bad if you get it wrong. This is the place to get it wrong, so that you don't do it when we have the test. All right, number 4 here. Actually, I'm not gonna do number 4, I'm gonna do number 5, but I need the directions before number 4 first. So the first thing is it says to give a description. So let's just stop right there. This is something that you're gonna do in words, okay? So when you look at example number 5, and it says to give a description, can you just put in words how the kid is messing with dad? What's the kid doing to dad? I mean, we had our parent, he was all nice and happy, till kids came along and started messing with him, right? So how did the kid mess with the parent? What about this piece? Say it again. Shifted left 3 and down 4. So that's what's going to go in our description. So left 3, down 4. That's all I need. That's enough of a description. Okay. So then number 2, use translations to sketch. In other words, we're not using a calculator anymore. In fact, on questions like this, I will say no calculator. Okay, so you're not using a calculator, you're using what we just learned. And so it says, okay, I gotta take my dude left 3, down 4. All right, so hang on. When I went through the Library of Functions video with you, this is a big deal, okay? So hang on to my every word right now. When I went through that video with you, every single graph, I gave you some important points. All right? Now, would you do me a favor? Go in your notes to the Library of Functions. Go in your notes to the Library of Functions. This is where you would have gotten this off of the video. And I want you to go to the square root parent. The square root parent. And I want you to look at the 3 points that you marked on the graph, because I marked them on the graph in the video. What's the first point that I marked on the graph for you? 0, 0, because the square root of 0 is 0. Okay, so I'm going to keep that in my mind. I'm not going to put it on paper just yet, okay? What was the second point I marked? 1, 1. Why? Because the square root of 1 equals 1. And if you remember, what I said in the video was, what's the next pretty square root? Yes, square root of 1 is pretty, but square root of 2 ain't. Yeah, the square root of 4 is 2, so you graph the coordinate 4, 2, right? So those are the 3 points that is part of the memorization for your graph. Okay, so then let's go over to our graph on that we're about to do. All right, so we started at 0, 0. Don't write that down. I'm going to erase it. We started at 0, 0. Okay, but I want to take that point and I want to move it left 3 units and down 4 units. And this is going to be my new starting place. Okay, so take that guy, move him left 3, down 4. So let's see, left 3, down 4. This is my new starting place. It's my new origin. Okay, now remember from the library, from the origin, didn't you go to the right 1 and up 1? Then from our new origin, let's go to the right 1 and let's go up 1. Okay, I don't even have to, there's multiple ways I could show you how to do this. Okay, this is just a way that I'm showing you. And then you remember in the parent how you went back to the origin and you went to the right 4 and up 2? Well, let's go to our new origin. And let's go to the right 4 and up 2 from that new origin. And now those are my 3 points that I can use to draw my swoop. So those, and every single library, every single parent I gave you has 3 points that are really important to use. So you need to know how I got those. You might need to want to go back and watch that video if you're not understanding what I'm talking about. Okay. All right, now the last thing I had to do is to get the domain and the range. Yeah, that's all I had to do, get the domain and range. So what's the domain for my new graph? Remember, domain is left to right. What's my new domain? -3 to infinity. All right, what's on that -3, folks? A bracket. All right, somebody else, what's my range? What's my bottom value all the way up to my top value? -4 to infinity. And what do you want on the 4? Okay. All right. Here's a tip, and oh my word, this is such an important statement. Such an important statement. Okay. Hang on, I got to remember what it says. It's so important. Yeah, okay. So anything inside the parent, anything inside the parent. So far, anything that was inside, what did it cause my parent to do? Which direction did it shift? Lefts and rights. Okay, now I'm not gonna put down lefts and rights, I'm gonna put down horizontal. Okay, left and right is horizontal. Because this is gonna carry over to my next section. All right, so anything on the inside of the parent is gonna cause horizontal changes. Anything on the outside of the parent is gonna cause vertical changes. Okay, so anything on the inside of the parent causes horizontal changes, anything on the outside causes vertical changes. Okay? So any questions about that? Zoom, you guys, any questions? No? Okay, so what we're gonna do now is I'm gonna go ahead and I'm gonna get a start on the next section. Okay, because what happens is I always get bogged down in 2-3 and 2-6, and then my students feel kind of like for the text. Okay, I saw the calendar somewhere. Where did I see it? Somebody had a calendar out. Yeah. Is that I'm on track today, right? Nuh-uh. May I? Hang on a second, guys. I'm losing my mind. It's okay. We're supposed to go to 2-3 because sometimes we cover 2 sections today. All right, 2-3 it is. Okay. So here we go. I said I always get bogged down. Got bogged down earlier than I thought I did. Goodness. Okay. Nothing like making you just, panic right during the middle of class. No, we'll be all right. Those first blank sets exactly what I just said. Okay, so I'm not gonna write those again. You've got them. You can fill them in on your own. Did I lose somebody over there? All right, so let's do a little bit more graphing. On the calculator. Okay, this is new. When you look at these guys, what's my new operation now? Yeah, I'm multiplying. I'm not adding and subtracting, I'm multiplying. Okay, so go ahead and put those in there. And then show somebody nearby. It's probably wise on this one to just do the parent and one of those. If you do all 3, on this one, all 3 is going to get a little muddy. All right, you have it? Okay. So for those of you who graphed the parent and you graphed the Y2, how does it appear that the kid is messing with the parent? How would you describe that? Makes it wider? So the parent was maybe like this and this guy is wider? Y2 is wider? Is that what you guys got? Yeah, I got skinnier. Did you do Y3?
I just did all 3.
Oh, gotcha. So you didn't know which one was which. Okay. So yeah, that was why I said only do 2 on there because then it might get confusing. So yeah, so the 2 x squared makes it get skinnier, doesn't it? Okay, let's take a look at some of these questions. You already answered the first one. What operation is happening? You already told me. Say it again. Multiplying. Is your multiplying on the inside of the parent or on the outside of the parent? Where? It's outside, isn't it? This is the whole thing about, I used Mary Alice slapping somebody, right? Was it you, Devin and Mary Alice? Yeah. So this is the whole thing about that, where my 2 out in front is too far away to be slapped by the power. Okay, the only way that 2 could be slapped by the power is maybe if it looked like this down here. Okay, where my 2 is on the inside. Now it's close enough to be slapped because everything inside the parentheses is getting slapped. Okay, so so number 2 then, the operation is outside. Okay, so remind me one more time. Anytime something is outside the parent, what kind of changes are occurring? They're vertical changes. They're vertical changes. Okay, so you're telling me, yeah, my graph got skinny, but vertically what happened? Vertically, again, vertically is up and down. Let me make sure that I'm on the camera here. All right, vertically is up and down. So I am stretching vertically, which is what caused my parabola to get skinnier. Okay, just like if I stretched you from top to bottom, you would get skinnier. Okay, it wouldn't be pretty either. So, so vertically, I'm stretching that. Now, number 3, according to your answer to question number 2, the transformation is occurring vertically. Just said that. According to your direction, and we already answered that. It's being stretched. Okay. Now, if you graphed the third one, which was a 1/2 x squared, what happened on that one? It didn't get skinnier. It got wider because it was getting squished. That is not a mathematical term. It was getting compressed or shrunk from top to bottom. Okay, so I at the first I was stretching, and now I'm squishing. So I'm bearing under the weight, and I'm getting wider and wider and wider. Okay, so that's what's happening there for that third one.
You said it was stretching?
For the third one, that's shrinking. The second one is stretching. Hang on. This one here is a vertical stretch by 2. Okay, why is it 2? Because there's a 2 out in front. And then the third one is vertical shrink by 1/2. Justin, was that your question?
Yes, ma'am.
All right, does that make sense? Did that answer your question? Justin, did that answer your question?
Yes, ma'am.
Okay, sorry, I didn't hear what you said there. All right. So you already have the parents on your graph. Let's do one more set here. But before you do that, you're already punching buttons. Before you do that, okay, where is that multiplying? It's inside. What can we already expect to happen? It's going to be some kind of a horizontal change, because anything on the inside comes from a horizontal change. Okay, so now go ahead. Let's just graph. You already got the parent graph Y2.
Do you want us to graph all 3?
No, just graph Y2. All right. What did you find? So just describe it in the best way you know how. Don't worry about being mathematically correct first. Okay, so doesn't it still get skinny? Okay. But this is different, folks. Remember, I know that what's happening is horizontal. Okay, so if this is the original parabola, okay, this is dad, this is my parents. What's the only way that I can have happen from side to side? Not from top and bottom, but from side to side to make me do this. I have to have somebody on both sides of me squishing me this way, right? Okay, that's a horizontal compress, a horizontal squish. Oh, okay, a horizontal shrink is what we call it. Okay, now the result is that I'm still getting skinnier. Okay, but it's a horizontal shrink. How do you know it's horizontal? Because that multiplying was on the inside. Okay, so this is a horizontal shrink by 2. Yeah. So, okay, can you get rid of the Y2? I don't want it to muddy up your graph. And if you look at the Y3 in the graph. So now, Justin, I want you to graph the third one. You already know something's happening horizontally because it's going on the inside of the parent. Okay, now non-math terms, what happens? They got wider, right? Okay, so let's go back to the parent. Here's my parent, okay? What would you have to do to me from side to side to make me get wider? Wouldn't you have to be pulling me from side to side? Yeah, okay, so that's a horizontal stretch. Horizontal stretch by 2. 1/2. You were just looking at it wrong. It said 1/2 all the way, all the time. No. My bad. It's 1/2. Hey, look, you saw me make a mistake. I didn't die. Okay, so the hints and the tips, that's just actually for when I have you guys working in groups. Obviously, I'm not allowed to do that very much. I do it a little bit, but not very much, okay? So that's why I didn't do that. All right. Here's a third set. Okay, so let's go back to graphing the swoop. Only graph the swoop and only graph the parent and Y2. Parent and Y2. Now what happens? Yeah, it reflected around which axis? The x-axis. Now wait a second. Where is that negative? Is it on the inside of the parent or is it on the outside of the parent? It's on the outside. And anything that's written on the outside of the parent is supposed to affect my graph how? Vertically. All right, watch. Okay, so basically I had my swoop, right? And then all of a sudden, it went down. Oh, that's a vertical change. It went down, and now it's no longer a swoop. Now it's a swoop. Okay? Does that make sense? So that's a reflection over the x-axis. That is a vertical change. Reflect over the x-axis. Is number 3, is that even like legal? No? So go graph it. Let's see what happens. Get rid of your Y2. It'll mess you up. Because if it's illegal, it'll just say error. Oh, what, did you get a graph? Oh, it is so legal. It is not illegal. Right, you're thinking you can't have a negative inside the square root, right? What if your x value is -9? Then wouldn't that be a -9? What is a -9? Oh, positive, oh, see, I don't have any negatives under there. Remember that the negative symbol, that just means opposite, remember that? Okay, so it's just the opposite of X, that's all that means. So it's totally legal. Now, can you describe to me what happened to the parent? Yeah, it reflected over the Y, so it was going up and to the right, now it's going up and to the left. Okay, so where was this negative? Oh, it's inside, and anything on the inside causes what kind of changes? Horizontal. Okay, so take a look. I was going swoop, and now horizontally, I'm going this way, right? It's still a horizontal change. So that's still, my rule is still holding fast there. You were expecting what?
Yeah, I found that.
How do you say that? Wow. Yeah, I don't know how to say that. Okay. So for this set of rules, let f of x mean the parent. Okay, we already did that. A is going to be a positive number. Okay. So look at the way I've written this first one. My A, my number. What operation is that? Multiplying. Is it on the inside of the parent? Is it on the outside of the parent? Outside the parent. So what kind of changes do we expect then? Vertical changes. Okay. So what is the value of A on every single parent in your library? So you might need to go back, or at least in your mind, go back and think of all the equations for all the parents in your library, all 6 of them. What's the A value? 1, right? 1 x squared. 1 times the square root of x. 1 times x cubed. Okay? In this case, my A value is 1. You already told me what direction is affected since my A is on the outside. The vertical change. Okay. Now, you've already found this out, so basically you're just giving me what you've already seen. When that A value was bigger than 1, you might have to go back, to remember, but when that A value was 1, remember this is a vertical change, how did it affect my graph when the A value was bigger than 1? Yeah, it was a vertical stretch. Remember, we did the 2x squared and it was a vertical stretch. All right, so if A is bigger than 1, we've got a vertical stretch by A, whatever that number is. And then when A was smaller than 1, stop right there. Remember, A is a positive number. I already told you A was positive. Okay, so I'm not dealing with negatives. All right. So when A is, basically you could say A is between 0 and 1, smaller than 1, but still positive. What happened? Again, we're talking vertical. Yeah, remember I was squished from top and bottom, so that caused it to get wider. That was a vertical shrink. That was the first set we worked on. The second set that we worked on was something that looks like this. Now where is my A? It's on the inside, so what is the direction that's going to be showing? Horizontal. Okay, so go back. So when my A was bigger than 1, so I was still using the parabola parent. When my A was bigger than 1, how did that affect my graph? What was it doing? And you gotta think horizontally. Remember, I was being squished from the 2 sides, so that as I was squished from either side, it was getting skinnier. Remember that? So that's a horizontal compress or a horizontal shrink. And then the last one, when A was smaller than 1, what was happening on either side of me? Yeah, somebody was on both sides of me, pulling me from side to side. Okay? It caused it to look wider, but it was a horizontal stretch. by A. What did the negative out in front of the parent do to my graph? Good, reflect over the X. And then when my negative was inside the parent? Yep, reflect over the Y. All right, let's put it all together then. Let's put it all together. Notice that the directions here only ask you for a description. You're not doing any graphing, don't worry, we're gonna get there, okay? But all you're being asked for is a description. So just describe to me in words what's happening. Let's start out by using some of the easy stuff. Like, what does that guy tell me to do? Left 3. Remember, adding and subtracting on the inside, you're gonna go left and right, and it's backward from what you expect it to be. Okay? Another easy one, what's this guy? Down 5. Okay? What about, I actually have 2 pieces out in front, this and this. Okay, so we have to describe these separately because they have 2 separate jobs, right? So let's look at the negative. What does that piece tell me to do? Reflect over the x-axis. Okay, and what does the 2 tell me to do? Okay, so it's a vertical stretch by 2.
Yeah.
Right? Any questions? Go with that. We're going to apply to the graph. Okay, and we're going to graph without a calculator. Okay, let's write some equations. Let's write some equations. All right, so that example number 2 says that we've got the graph of x cubed vertically stretched by a factor of 3. Let's stop right there. How am I going to write just that piece? So it's going to be 3, and what kind of an operation am I going to be doing? Multiplying, and is it going to be inside or outside the parent? It's going to be outside. Okay, let's keep on. I'm not going to write anything down yet, but let's keep on reading. Then it's reflected across the x. So what do I need to do with that? Okay, that 3 needs to be a negative. And then lastly, shifted 8 units up. All right, where is that going to go? Plus 8 outside the parent. Okay, so let's put it all together. Remember, it's an equation. So y equals, or f of x equals, okay. You said negative 3 x cubed plus 8. Is that right? Yep, it is. Okay. Can you write an equation for number 3? You write the equation for number 3. Does anyone on Zoom want to attempt to answer this one? Justin, November, Brianna, any of you guys? Blake already did one. No?
No.
Are you being a chicken?
No, I get it when you explain it, but now that you're asking me to do it by myself, I'm like,
Not quite so sure, huh?
right.
Yeah, I understand that. I understand that because it takes practice. Justin and November, what do you guys think? Justin's just grinning. I'm getting nothing from him. And November, what do you think?
I mean, I guess it would be the y equals the square root of x cubed plus 2.
Hang on a second, November. It's not a square root. I know that's written really tiny. It's actually a cube root.
Oh, a cube root. Okay.
Yeah. Sorry, that's kind of hard to read on the screen probably. So it's a cube root.
Cube root plus 2 plus 1.5.
Okay, so let's talk about just one piece at a time. So the shifted 2 units left part, November, how did you write that part? Or where did you put it?
I put it beside the cubed root, so just plus 2.
Inside or outside the cube root?
Outside.
Okay, what do you guys think? Inside or outside the cube root? Inside, why inside? Remember, it's anything that's horizontal and left is horizontal should be on the inside.
Okay.
Okay, so how should I write just the 2 units left part, guys? Yeah, so we've got the cubed root of x, what'd you say? Plus 2. All of that is on the inside of my cube root. November, does that make sense?
Yeah, I think so.
Okay, because anything to the left has to be on the inside of the parent, and the parent is my cube root. All right, let's read the next phrase. Vertically stretched, let's stop right there. Okay, so this is vertical. Where does it have to go? Somewhere outside the parent. And a vertical stretch, what kind of operation does vertical stretching always use? Multiplying, so where am I going to throw it? In front of my cube root. And then the last piece says shifted 9 units down. Minus 9 on the outside. Now, before I go any further, I want to show you something because sometimes students will handwrite this and it'll look wrong even though their brain was thinking correctly. So I want you to look at your paper. Is it possible? Was that a plus 2? Yeah, how does what I just wrote look different than what was over here on the blank? How could this be misunderstood? Yeah, it looks like I've got 1.5 cubed times, or what? Times a square root. Okay, and that's not what it was. It was a plain old 1.5 to the first power times a cubed root. Okay, and so sometimes if you're being sloppy with your handwriting, that's difficult to tell what it was that you meant. Your brain was thinking correctly, but I didn't know that because I couldn't read your mind. Okay, Mary Alice? Mary Alice, you can. That's not illegal or anything. Mathematicians are borderline lazy, and that's an extra set of strokes that we just don't usually put in there. The 1.5 in parentheses would also be fine. And not as, it's not that it was weird, but it's just not normally done. But it's not wrong. It's not wrong. I would never mark that wrong. Okay. So while I'm here, we're about to go graph some. I've only got a few more minutes. But let me mention this. When it comes to your test, okay, your test, I've already told you, is going to be taken on the computer in my lab. If you don't show me work on a question, I don't care how right you got it, you're not getting credit for it. Okay? Now, sometimes there's no work to show. So for instance, in the last 2 questions, there was no work to show. In fact, this is probably going to just be a type it in kind of question, right? So there isn't any work to show, and so I'm okay with that. But let me tell you, if there's anything that requires any kind of brain work, it better be on paper or I'm not giving credit, even if you have the right answer. And I've thrown in some multiple choice questions. But listen, this is not eeny, meeny, miny, mo, A, B, C, or D. This is, I showed work, this is why I answered B, or this is why I answered whatever, okay? So even multiple choice questions, you must show your work. Okay, can we get into a graphing question? So next time I'm covering 3.1, so I gave myself a little bit of a cushion, okay? Since I didn't finish what I wanted to finish. I'm behind. Already. Okay, so that also means your 2/6 is probably due at midnight on Sunday. Somebody's gonna need to text me to remind me to change that due date. Okay, so if 2/6 is due on Sunday at midnight, somebody text me. So I'll change it, otherwise I'm gonna forget. Okay, so graphing. I already have the parents on there. This is graphing without a calculator, okay? Now, do you remember how I told you that when you memorize the graph, there's always some specific points you need to know, okay? So on this one, the video, you started at 0, 0, and then you went to the right one and to the left one. How far up did you go? You can see it on the graph. 1. So to the right one, to the left one, up 1. And then you also went to the right 2, to the left 2. How far up did you go? 4. Okay, because 2 squared is 4. Okay? I love to say that really fast. You guys ready? Because if you close your ears for a split second, you're gonna miss it. Ready? I love saying right 1, left 1, up 1, right 2, left 2, up 4. Because that's what we're doing on this parent. We use the squaring parent over and over and over and over again. Okay? All right, so what I want to do then in these last few minutes, let's get a description for that middle guy. Okay, just a description. Just tell me in words, how is this kid messing with the original parent? What's one thing? Okay, so what kind of a stretch? A vertical stretch by 2. That's important. What else? Okay, so to the right 2, and then lastly, up 1. All right, so let's go put our new graph on. Forget about the vertical stretch for a minute. Just forget about it. Let's just pay attention to the right 2, up 1 stuff, okay? Go over here to your origin. Let's take the origin and move it to the right 2 and up 1. So to the right 2, up 1, I have a new origin. You with me? Okay, now this is gonna be the tricky part. If you lose me on this, or if you let yourself blank out, you're gonna have a hard time with this next part, okay? Do you remember my statement that says, right 1, left 1, up 1? Okay. This is a vertical stretch. I'm not gonna mess with the right 1, left 1. I'm gonna keep that the same because that's horizontal. Leave it alone. It's my up part that I'm gonna mess with, okay? So instead of going up 1, I'm gonna stretch it by 2, so that's a 1 times 2. So instead of right 1, left 1, up 1, I'm gonna go right 1, left 1, up 2. So go to that new origin, go to the right 1 and up 2, go to the left 1 and up 2. Let's do that again, okay? Because remember the next piece was right 2, left 2, up, what's the parent do? Up 4. Again, don't mess with the rights and the lefts. That's horizontal, that's not vertical. And this is a vertical stretch. So we're still gonna go right 2, left 2. But now I'm not gonna go up 4, I'm gonna go up 2 times 4. back to the origin. Go right, not with a eraser, Miss Roberts. Go right 2 and up 8. 2, 4, 6, 8. Here we go. And go left 2 and do the same thing. Okay, now you have plenty to draw. Can you tell that this guy is skinnier than the original? Yeah, it was stretched vertically. Okay, all right, I don't have time to do the last one. Okay, what we'll do, I think I've only got like 3 questions left. 1, and then that one, okay, which has a couple of parts. So 2 questions, 1 with a few parts. We'll start out with that next time. I'll be able to do 2-6 and probably even start 3-1. 3-1's not on the test, so if I get to it, wonderful. If I don't, oh well. All right? Have a good weekend, folks. Like I said, if that due date's wrong for 2-6, please let me know.